Okay, there we go. So first question, 4.1. See if we can get it done in 25. 9 to the third power. What does that mean when you put little numbers in the upper right-hand corner? Yeah, it's a repeat symbol, isn't it? It means repeat the 9 3 times, multiplied by itself, huh? And we're just going to stop here. No more, they're not even, no answer, no final answer. How do I know? Well, right over here it says, do not simplify. Just leave it. They just want to make sure you're really clear. What is 9 to the third? It means 999. 9 times 9 times 9. Just want to make sure you're clear on the meaning of that. Is that good? 9 to the third means 9 times 9 times 9. What do you do if you're doing Math Excel homework? And like if you multiply this out, you'd get, I don't know, some big number. 729 or something. Anyway, so they don't want you to say that. How would you know? Let me go back over here. Let me try this one. 4d to the fourth. Same thing. They want you just to write it out and not simplify. So write that one out. Is that 4d, 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 4d? No. How many fours? Just one 4, huh? We all clear? They're just making sure you know that. Right there's just one 4 and 4 D's. There we go. 4 D, 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 D. There we go. That's all they want. Now, how would you write in math something so that you could do 40, 40, 40, 40? Yeah, that would be parentheses like that, huh? Then that would be 4 D's, right? But if there's no parentheses, then the power is only on the thing it's right on, nothing else. So it's saying 4 D's, but not 4 4s, huh? The 4 power is only on the D. They're just making sure you know that. Ready? Do you know this already? What is n to the 0 power?
1.
Is it 1? Is that right? How do you do a 0 power? I mean, like if I did n to the third, that would be n times n times n, right? 3 times. If I did n to the second, that'd be n times n twice. If I do n to the first, that's just n once. So how do you do n 0? Like no n's at all? Why isn't it 0? It's 1? Really? You guys sure? You're right, it's 1. And you know why it's 1 and not like you know what I mean? Right, shouldn't it? You guys tracking with me here? Maybe I should write that out more neatly. Right? I mean, wouldn't we think, you know, we know what n to the third means. It means 3 n's multiplied. We know what n to the second means. It means 2 n's multiplied. We know what n to the first means. It's only 1 n. So shouldn't that be no n's and just 0? But you guys are saying it's 1? It is 1. You're right. You know why it's 1? Because Mr. Heron says so. Yeah, you know. After I die, who knows what it'll be, because somebody else will say so. No, that's that's not it. It always reminds me of you know, I'm pulling authority ranking out. We had years and like 20 years ago, a long time ago, when my kids were little, and my wife had a good friend. We lived in a different town then, and they'd shop together. So anyway, so we had this friend, and the way she'd always parent is she just didn't want to confront her children, I guess. So if her little child, they'd be in the mall or something like that, and one of her little children, toddler, would be going crazy wanting something. You know, I want the whatever, I want the candy apple, or I want. And then she'd try saying no a couple times, and the child kept saying, no, why, and throwing a fit. And so she learned to say, the man said no. And she would just say, the man. The man said no. The man said no. And so that worked for, I guess, a few months. You know, it's like, oh, the man said no. The man said, no, I guess I can't. You know, like there's this authority, this random man hovering around. Not her husband, he's at work. Who knows who it was? It was the man. And one day, my wife was out shopping with her, and she tried that line, and the kid finally went, Mom, who is the man? And then she had to switch tactics at that point, right? That wasn't going to work anymore. Anyways, it's kind of funny. All right, so the man says so. No, the man does not say so. That's not the reason. Isn't that weird? I mean, isn't that weird? Why is it 1? Doesn't it seem like it should be 0 or something different? I mean, why 1? First off, let me mention, what's 7 to the 0 power? I'll give you a hint. It's the same thing. It's 1. What's 5 to the 0 power? It's 1. What's 2,813,567 to the 0 power? 1. How many of those you want in the test? Those are nice, huh? It's always 1. Anything to the 0 power is always 1. Now, why? Doesn't that seem bizarre? Powers are like repeat symbols, right? So if you repeat something 0 times, shouldn't you have 0? Why should you have 1? It's not because Mr. Aaron or the man says so. Let me show you why. Let me give you a reason. Let me show you a good reason. Think about 2 to the 3rd with me for a minute. What does 2 to the 3rd mean? Doesn't that mean 2 times 2 times 2? What does that equal? Yeah, 2 times 2 is 4, times 2 again is 8, right? All right, so what? Well, what's 2 to the 2nd power? It's 2 times 2, which is 4. 2 to the 1st power is just 2. Okay. Next comes 2 to the 2nd. I'm just following the pattern, right? I'm just going to prove to you that math is not making up weird things here. They're just following the yellow brick road of logic. That's all they're doing. Look at the pattern. 3, 2, 1, 0, right? It's just whatever comes next, right? Okay, so what's the answer got to be? Without, I mean, we know there's some rule, but pretend you don't even know the rule. Pretend you're trying to discover the rule. And you're like, I don't know. What's the answer? What's the answer? And you're not going to say it's 1 because Mr. Aaron says so or the man says so. Just, no, logic. Just logic, right? In math, the man is logic. It's logic. That's the throne, right? You tell me what's happening. It's logic pattern is all it is. Look at the pattern. How does 8 become 4? What do you got to do to 8 to make it 4? What's happening to those numbers every time? They're all dividing by 2, aren't they? Divide by 2, divide by 2. So do it again. 2 divided by 2? There it is. That's the pattern. It's exactly what it is. You could do that with any number, right? So 7. What's 7 to the 3rd? Well, 7 times 7 times 7, which is, I think it's 343. And then 7 to the 2nd, 7 times 7, which is 49. And 7 to the 1st is 7. What's happening here? So what's 7 to the 0? What's happening every time? Divide by 7, divide by 7, divide by 7. It's going to be 1. It's going to be true for anything. It's the truth. It's nobody's opinion. It's the truth. So, there we go. So anything divided by, no, not divided by 0. Anything to the 0 power is 1. So those will be, okay. So VW to the 1. What's anything to the 1st power? It's just itself. This is VW. There's nothing to do there, huh? It's just VW. Good? But I don't know why they asked that question. That's a dumb question. All right, questions. We've got hard questions. K to the 3rd when K is 6. So I just want you to plug in 6. Remember when you plug in the formula, you put parentheses around it? So K to the 3rd, K is 6, that's 6 to the 3rd. Hit the buttons on your calculator. 6 times 6 times 6 is it 216? I think. Whatever it is. I'm going to flash off that. You okay there? Just plug it in, hit the buttons on your calculator. Anybody know the area of a circle formula? Good memory. Yeah, area of a circle. Pi r squared. They're telling you to use, for pi is 3.14. You probably already knew. The r is 52. So it's just buttons on the calculator, right? 3.14 times 52 times 52. It's going to be, I think, 7,000 something. 7,800 maybe. Might be 8,000. I don't know. Somebody got a number there? It's between 7,000 and 8,000. It's high 7,000s, I think. Or low 8s. 8490.6? 8490.52. Okay, I was off a little bit. 8490.56. Anybody else getting that number? Mm-hmm. All right, there it is. That good? So just use the formula pi r squared. Plug in the pi is 3.14 and the r squared. Good? All right. Pi. What's pi? I mean, it's 3.14, but what is it? Where'd that come from? Did the man just suddenly say, I know what pi will be? Pi will be 3.14. We discovered it. It's part of the warp and the woof of the The world as it's been created. Circles. They started discovering it way back in the Egyptian days. I better watch my time. I'm a wannabe history teacher. Really, really quick. They started looking at circles. It's basically if you measure around a circle and then across the middle, any circle, little, big. So back in the Egyptian days is the first, I think, recorded like estimates of pi. They would measure around like logs. You know, they'd cut a tree and they'd measure around, and then they'd measure across. They'd divide those two numbers, and they'd get about, depending on how accurately they did that, 3.14. Then they'd have a tiny circle. They'd find like a disc or something. They'd measure around, measure across the middle, divide those two numbers, 3.14 again. No matter how big or small the circle is, the more perfect the circle, the more exact they're measuring, the closer they would get to 3.14. It turns out it is the ratio of any circle, the circumference that's around, to the diameter, right? Well, too much time. Yeah, enough said. Moving on. Negative powers coming next. Negative powers. 10 to the minus 2. What does that do? They may know. I'm just going to tell you. I'm not going to give a deep reason why till later. Maybe in next week or something when we have more time, we'll talk about logical reason why. But for now, I'm just going to give you the rule. Some of you probably already know. What's a negative power do? Flips it to the bottom. And negative powers, I always say this way to help you remember. It's like there's somebody at their job that's unhappy. They're going to jump to a new job. So that's the deal with negative powers. They're unhappy where they're at in the fraction. They're going to jump to the other side. So it's going to jump down. And after it jumps, then it's positive. So let me just write that. Negative powers jump to the other side of the fraction, then become positive. Does that make sense? Negative powers jump to the other side of the fraction, then become positive. So and there's nothing left on the top then because the thing jumped down, so you just put a 1 up there, huh? And I think they just want you to leave it that way. Yeah. That's it. I mean, you can make it 1 over 100. Same thing as 1 over 100, huh? 10 times 10. Whatever. Both are right. Doesn't matter. I think they want it this way. Both are right. Questions on that? Makes sense. Negative powers, they're negative. They're unhappy where they're at. They want to jump to the other side of the fraction. Then they become positive. That one, 1 over n to the minus. What's going to have negative powers? Again, they're unhappy. So if they start on the bottom and they're unhappy, where are they going to go? They're going to go to the top, aren't they? So that negative power, he's unhappy. He's like, I don't like it here. He's going to jump to the top, and then they become positive. They're happy after they change to the new job. Doesn't always work that way, huh? When you change your new job, but well, it works for the powers. So they switch to the other side, then they become positive. And that's just it. We don't have to put a 1 on the bottom, right? 1s on the bottom are not required. So that's just it. We're done. That makes sense? Negative powers are unhappy where they're at, jump to the other side, then they become positive. We're supposed to be taking the practice exam right now. Okay, so 1 over 6 to the 9th. You know, I would say, hey, that's done. What do you want me to do? It's all good. Well, they specifically want you to make it have a negative power. Right as a negative power. They want you to change it and write it as a negative. Well, how do you do that? 6 to the minus 9, huh? Because minus 9 would make it jump down and go back to the way it was. Does that make sense what they're wanting me to do? They just want to make sure we understand this rule about negative powers or other side. Good. That okay? Okay. 4 to the 3rd times 4 to the... All right, I'm going to do multiple choice. A. All right, there we go. So multiple choice. 4 to the 3rd, that's a times. 4 to the 3rd times 4 to the 7th. What does that equal? A, B, C, or D, or E? Let's do it as a group. Are you ready? Everybody want to look up there for a second? 4 to the third times 4 to the 7th. Think about what answer you think is right. Are we all ready? How many say A? Couple, 5, 6, 7, 8. Say A. How many say B? Nobody likes B. How many like C? Maybe 6, something like that. How many like D? Nobody likes D. How many say it's none of the above? It's something other than something. No. So what was it? What did you guys like? A and C? Were those the two you liked? A and C were the two you liked. If I was to do a clicker or something, A and C got almost all the answers, right? And I think, was A the most popular? I think A was the most popular. Barely, right? So we should just do whatever majority says, because math is just by majority. One year this rule's voted in, the next year that rule's voted in. No, it's obviously not. So can anybody like give a good reason why their answer's right?
C's right because you have the same, you have 4 on both sides, and you just add 7 and 3.
4's right. I'm sorry. C's right because you have 4 on both sides.
Yeah. And then you have the top, what, exponents?
Uh-huh.
So you just add them.
So you just add them?
Yes.
Does that convince the other camp? No, not convinced. Do you have an argument for the other camp?
A is right because the numbers multiply, then powers add.
The numbers multiply and the powers add? Why? Why do the numbers multiply and the powers add? Because the man said so? I'm going to be like the toddler here. Why, Mommy? Why? But I hope you are that way with math. Why? So I don't think you're going to convince each other with just throwing rules, because that's basically throwing authority, right? But say, well, some math book said so, right? Well, the other person go, I don't remember it that way. Let's don't do that. Let's do logic. Truth. Talk to me about truth. Math is always best by truth. Can anybody give me just truth, not some authority, just something that we would all of us would go, yeah, that's true, isn't it? What's true? Let me help you. What does this mean? All by itself. What does that mean? Just what's true? What does that mean? Yeah, doesn't that mean 4, 4, 4? Multiplied? Right? Don't we all agree? Little numbers in the upper right-hand corner mean repeat it that many times multiplied, right? You all know that. I'm not saying something you don't all know. Times 4 to 7. What does that mean? What's 4 to 7 mean? Well, it means 7 of them. 3, 4, 5, 6, 7. Multiplied again, right? That's what we agreed. And what's in the middle of them? Multiplied. So what do you got there? Don't you get that? You don't got 10 16s, do you? C is right. Clearly. So clear when you look at truth. Truth is best. That's how you want to learn math and science. Not memorize some rule. You'll forget those rules. I do even. Well, not now. I teach it day and night. But when I was a student, I did. Right? I mean, you can memorize all the rules perfectly. If you try to do math by living and dying by rules, you will die to some degree. It's much better logic. Logic. Look for the pattern. Think about what it really is. That's all I did there, right? What is 4 to the third? What is 4 to the 7th? What do you got? 10 fours. And you go, yeah, but 4 times 4 is 16. Yeah, don't do that. That's wrong. I don't care how it feels. You know it's not true, right? Because this is what's true, right? So the rule we see is if you have same bases, you add the powers. You do not multiply the bases. You don't go 4 times 4 is 16. No matter how it feels. It ain't true, right? That make sense? So same bases multiplied. What do? Add powers. Keep the base the same. That make sense on that? That good? You getting the hang of doing math a little bit more? Always pursue truth. Always think about what those things are. All right. So 5 to the 29 times 5 to the 27. So what do? On that, do I actually multiply those 5s and make 25? No, I just think, okay, I'm not going to write it all out, 5 times 5 times 5, but we know that means 29 fives, huh? And we know that means 27 fives. Just brrr, a big string of them, huh? So you just add those up, don't you? 29 times 7 was that? 16, 56 fives. Not 56 25s, but 56 fives. Is that good? Making sense? Just add the powers, keep the base the same, because that's what's true. It's what it really is, huh? Makes sense? Is that more interesting to you? I think math's more interesting when it makes sense. It's not just rule after rule after rule. How boring, which maybe that's how you feel. I would have never majored in math if it was just rule after rule after rule after rule, which is what a lot of people think it is. It's because they're not seeing the logic that's flowing through it. So let's go for the logic. You'll do better. It'll be all right. So z to the minus 7 times z. Okay, what do we do with, let's do the negative power thing first. What do we do with negative powers always? They're unhappy. They're negative, they're unhappy where they're at in the fraction. They're going to jump to the other side of the fraction. Now, what about the other z? What power is on the other z? There's nothing showing. Positive regular 1, huh? So is he happy? Yeah, he's got a positive power. He's happy. But the other guy is going to jump down. So what do you get? Z to the 1 over z to the 7. Is that good there so far? Very good. Does that make sense so far? Right? So negative powers, they're negative, they're unhappy where they're at, they're going to jump to the other side, then they become positive, regular, happy. Good so far? And now, what are we going to do with these? Yeah. Do you know the rule that you subtract the powers? 7 minus 1 is 6. And there's really nothing on the top, which means you put a 1, right, whenever the top vanishes. And there it is, we're done. Now, I just said a rule, and I said I'm not into rules. At least I'm not into blind rules, rules without understanding why. Why do we subtract the powers there? I think you know that one pretty easy, right? What is z to the 7th? It means 7 z's, 4, 5, 6, 7. And z to the first is 1 z. See, there's a cancellation. That's what's really happening. We just don't want to show that all the time. Z to the 7th is 7 z's, 1 z, cancel. You got 6 z's down below, huh? It's just normal cancellation. But subtracting the powers is just a quick way to do that. Bless you. Does that make sense? Is that okay? So, yeah, here, let's do another one and I'll write some rules out. We good there? Sections, so. Okay, so x to the minus 7, I'm getting a little scribbly there. X to the minus 7 times x to the minus 7. All right, are those guys unhappy? So what are they going to do? They're going to jump down, right? When they're negative powers, they're unhappy. So they're both going down, and they're both becoming positive regular 7s after they jump down. And now, these guys are on the same level, so what do? Powers add, right? So powers on the same level add, powers that are vertical subtract, huh? And we're done right there. Is that good? Making sense? So negative powers jump, then they become positive, and then powers on the same level add. Combine that way, right? Good that way. Can I flash off that one? We good? There we go. So 17 to the 2nd over 17 to the 9th. So try that one. Finish that one up. So what are those powers going to do? Subtract 9 minus 2. 7. And the bigger one's on the bottom, so it ends up on the bottom, and you just put a 1 on the top. Is that okay? Does that make sense? That's because the top is 2 17s and the bottom is 9 17s. And there's cancel, 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 and there's 7 left over in the bottom. Huh? I don't want to write all that out every time, but that's really what's happening, right? Is that good? Just so when powers are vertical, we just subtract them. if they gave me the powers side by side, I would add them, wouldn't I? Right? If powers are vertical, we subtract. If they're side by side, we add. Because that's what's true. Is that good? Well, that's why I just subtracted those powers. And the bigger one was on the bottom. The answer always ends up where the bigger one is, huh? Bigger one was on the bottom. Okay, so p over p to the minus 5. What are we going to do here? What's the power for the p on the top? Positive 1. Okay, so let me ask you, are they both unhappy or just one of them unhappy? Just the bottom power's unhappy, right? So only he's going to jump. The top one's like, I'm good up here. I'm not going anywhere. I'm staying put. Right? So the bottom is like, I don't like it here. I'm coming up. Right? But the top one's staying put. The next problem, they'll both be negative, so they're both going to jump because they're both unhappy. Does that make sense? Only the negative powers jump. They're negative, they're unhappy. So, okay, so what? So the p to the 5 comes up there. P to the 1's already been up there. And then they're side by side. So what do? Add them up. Done. Is that good? So only the negative powers jump. So if only one of them's negative, only one of them's going to jump. All right, one more. Okay, so b to the minus, is that 6? Yeah, 6 over b to the minus 2. So see how on this one they're both negative powers? They're both unhappy. They're both going to jump to the other side. So let them both jump. This one's going down, this one's going up. So b to the plus 2 over b to the plus 6. After they jump, they become positive, right? They're unhappy where they're at. They're negative. They jump to the other side, become positive. And now what do? When the powers are vertical, instead of side by side, they add. When they're vertical, they subtract. Is the final answer going to end up on the bottom or the top? Where's the bigger one? The bottom, b to the 4th. You just put a 1 on the top. 6 minus 2 is 4. Is that good? All right, we are done with that section. Why don't we take a break? Take a 10-minute break. I'll give you the practice exam. Ooh, boy, look at the time. We'll come back, and we'll take it.